Hello and welcome back to the Alteryx Weekly Challenge for me, Nick Bignell. This is challenge number 127 and we are looking at the US Grand Prix Lap 2 from 2018. Okay, so let's, as usual, have a look at the start workflow or the starting file and then go from there. So your company is dedicated to retaining employees. Your task is to identify the active employees who are most at risk of leaving, defined as a probability of greater than 0.5. To do this, you need to build a decision tree and logistic regression. So we're looking at predictive analytics using a default configuration and choose the model with the highest accuracy as shown in the I output. You will use the field employee status. So let's have a look, see. So we have name, number, okay, employee status, employed or terminated. You will be using existing fields as the predictor variables in the model, department, pay rate, marital status, performance score, and age, and then we create a days of employment as a variable for the model, type double, and use the days as the unit. Okay. For current employees, use the date of 2018 July the 5th. Okay, calculate the days of employment. Okay, and then only active employees should be evaluated in the risk to leave. All records should be used to create the model, though. Okay, employee data in current and terminated employees indicates who will still be in the company and who has left. Okay, right, that makes sense. So let's start with sorting out this days of employment. So let's have a look what we've got data wise. So we've got a hire date, we've got a terminated date, and now and they're the two dates in there. So I want to create another one which is we're going to use for which is today's date, which is this 2018 7. So if we just pick that up in here, we can then use that. Right, okay, so in here we want to create a to date, and we want to create an if statement that says, so if is null, so if is null, and the field we want to check with is null is the date of termination, then we want to use this date, and then if we want to make this a date as well, and then else we'll use the date of termination. Okay, so that's easy enough. So that'll give us a date. Now we need to work out the diff between the start date and that date. So let's add a column and we'll call it days underscore of underscore employment. Okay, so that should give us that. And what we want to do is a date diff. So date time diff, and you can put the first, you put the last date, the to date, and then you put the first date, date of hire, and then the units we want to put is days, and this should be a double. Okay, need a quick on the back of that. There we go. Okay, so if I quickly run that, that will give us a number of days. Here we go, that they've been employed. Okay, so we can now use that in the model. If we look here, this is what we're trying to get to. So there's 7 employees here that are likely to leave. I think that's what it's saying. Okay, so we need to identify those. Okay, so now let's look at actual model. So in predictive, we can bring in a decision tree as one type, and now we want to configure it. So we're looking at employment status. and then we want to select department, pay rate, marital status, performance, age, and days of employment. Okay, it says leave it as is. Now if we stick a couple of browses on that, in the eye we should then see how accurate that one is. Okay, so if we look in here, waiting for it to render. Okay, so that has an accuracy of 89.3. Okay, so let's now bring in the logistic regression one. What I might do is just stick this in a container and close it. So it's 90, just before we do it, make it 98.3, I believe was the amount that we're looking at. Yeah, 89.3, right? That's the accuracy that we're looking at. So let's just close that. Okay, right, okay, and then we'll do the same with the logistic regression. Add a load of browsers on it, and then configure it. So again, we want to select employment status, and then we want department, pay rate, marital status, performance, age, debt. Okay, and then we run that. This will tell us the one that's the most accurate. Okay, so let's see if that renders. Okay, and this is 84.5. So 89.3 is more accurate. So therefore this is not the most accurate. So we'll just stick that in a container and close it for now. Okay. So we should be working with this one. Move this container down. There we go. And then what we want to do is build our model. So let's filter out from here. We can bring it back there. And we want to filter out the terminated. So does not equal terminated. Okay, so that will then just give us the actual ones that we're looking at, and then we want a score. So we can then bring that into the data, and then the model into the model side. Okay, so I need to rename. Maybe we can just get rid of some of these fields that we don't need. We do that. So let's just do that here. So we don't need this to date, which is that it's complaining about. Okay, let's do that then. So if I look here, and then we should have, yeah, we've got various different. Just have a look through. There you go. But looking at this, I can't see any that are. Let's just filter on greater than 0.5. So on the X terminated needs to be greater or equal than 0.5. I didn't see any there. Okay, yeah, it doesn't look like there's any there. I'm wondering if this is, because this is a while ago, I'm wondering if there's an older version. There's two versions in here, so you can choose different versions. Let's change the version. So we still want employment status, and we want department, pay rate, marital performance, and we want age and okay, and then just leave it as run. Okay, that's better. Right, so now we have the 7. Is it the same 7? Yes, the same 7. So we found our match, but we had to use an older version. Interesting. And if you use a newer version, it obviously uses a different model. Okay. So I wonder what would happen if we used the assisted modeling. Let's have a go with that. So, machine learning, assisted modeling, let's bring that in. We'll put that here, and then we'll bring in from the same point. Okay, so it doesn't like some of the doesn't support spatial, blob, date time, or date time types. Okay, so let's get rid of those types. We don't need them for the model anyway. So it says doesn't like the date types, so they're the only ones we have in there. Okay. Okay, so let's run that. Okay, now we can start it. We might just close this or extend this container to include this lot, and then close it because it's going to add a lot of time to the workflow. And we can look at this one. So if we go to start assisted modeling, and we'll just bring this back in. See it. There we go. Okay, so let's start building and see what we get. So we want the available target is the employment status. It's telling us we can do a classification on it. So let's go to the next step. Yes, we are sure we want to continue. And we can look at the data types. Right, so we've got employee number. It's come up with verified data type. So we can just call that an ID. And then age is in there, but is valid. So we want to do that. So also doing, is there anything else? Days of employment, manager name. I don't think we need that though. Now you turn that off. Well, we can keep it in there. Maybe it's a factor. Okay, and then let's have a look at the next one. Okay, so it's no data, missing data. That's good. It's now going to go through and select the features. So we can then undo this manager name because we don't want to. These are the ones that we're told to use. Okay, and then it's given us various different sorts. So let's go with these ones. So it's got logistic regression, decision tree, and a random forest as well. So that's the logistic regression. It's saying it's more accurate, 82.5, than the decision tree, which is interesting. And actually decision tree now is the least accurate. So let's okay, so let's select them then. I think we'll go with all three. Why not? Add all three. Okay, so we now have all three added. We need to add in this filter. Let's just take this one. So we copy that, paste. If we paste that here, we bring in the data from, actually it can be from here. And then what we'll do is then we just draw that all the way across for each of the models. So logistic regression at the top, random forest in the middle, and then decision tree at the bottom. Right, and then okay, page jump then. Right, okay, and then if we just open this again, we can then take this. It's probably going to be called something different. What would it be called? Well, we don't know until it's over. Right, well, we'll just run them and then we'll run them again. Okay, so that's now run, and then what we can then look at is, so it's given us an actual prediction here, employee status predicted, and then the amount here, so it's actually given us the 0.5, so we can use this field, employment status terminated, to is over 0.5. So equals or greater than 0.5. Okay, and we'll just use that all the way down. Okay, so let's have a look, see what we've got. So in the logistic regression, we have 15 potentials that are likely to leave us. In the random forest, we have 0. Okay, and in the decision tree, we have 1. Mitchell Delaney. Okay, is he in this one as well? Yes, he is. Okay, so 2 models are saying he's likely to leave. This one's saying a lot more as well. So there you go. So the model that you use does determine very different outcomes. We've got to be careful with models, I guess. But we did it with this one. We created this one up there. Thank you very much for watching. See you again next time.